Thank you, Lukman. Right. So, good evening, everyone. Thank you for joining today's lightning section. It is our pleasure to have you with us today. I can see new names. I don't know if Janet is new. It's the first time I'm seeing Janet. It's the first time I'm seeing Henry. Oh, Henry has been part of us, right? Well, is it Kevin or Kelvin? Kibat. Welcome. If Rishi's welcome. If today is your first time joining us, welcome. Welcome to Java, NAIJA-JAVA user group. It's a privilege to have you with us tonight. What we do, right? We share our knowledge among ourselves through meetups like this. Yeah, it could be monthly section, it could be lightning section. We also have a bootcamp ongoing. I'll be wrapping it up in a few months from now, and we have the privilege to assign young developers to mentors. So this platform is just a means of us sharing our knowledge. Yeah. Java user group is in all countries around the world, and we are privileged to have the one here in Nigeria. So if today is your first time joining us, I want to say a very big thank you, welcome. If you're not on our platform, in course of the presentation, I'll be dropping the links to our different social medias. Do well to join. At the end of the section, I'll give a brief announcement about our monthly section. But without wasting much of our time, because this guest speaker has been on this call like 10 minutes, 15 minutes ago, yeah? Waiting patiently for this hour. So I wouldn't want to extend this time. So we had this topic a few months back, and in course of making the post, I was able to share the link to the part one of this topic. So it's all about Spring Data JPA. Yeah, what it does in it or behind the scene. And today we are talking about it, and we are, I think it's the part two. Yeah, this is the part two of it. We already have the part one. If you're on our YouTube channel, you can browse about it to visit it. Yeah, but this just react to your favorite emoji to welcome the speaker. Is no other person than Awoniyi. This guy is always a pain in my life. Just okay. I'm just seeing John, Janet, Joseph. Okay. I'm not seeing Blessing, Donut. I'm not seeing Kibat reacting. I wonder, are you sure you did not offend these guys? All right, so welcome. You can have the floor.
All right. Good evening, everyone. Or good day. I don't know who is where currently, but yeah, good day. And I hope we've had a very great and lovely day. And thank you very much, Daria. It's an opportunity, a great one, to have the session again. And like she rightly said, this is the part two of something we've been, on to Spring Data. And I appeal and apologize. Please, can you see my screen? Can you see the slide actually? Because I switched to a window. I want to know. Hello? Hello?
Yes, I see it.
All right, great. Okay, thank you. So I want to appeal and apologize beforehand. This is quite, like you say, the advanced part. We've had one initially, and that we broke that down. That was friendly beginner, while this is the advanced part, basically. So if it's going over anyone's head also, just like Gloria said, we could go back to you can go to our YouTube channel. Link will be posted in the chat soon. Go back to our YouTube channel and watch. In fact, we have a series of we have like just a wealth of knowledge, a repertoire of knowledge there. Just go consume, right? And it will all make sense. So for the last time we met, we talked about the internals of Spring Data JPA. And very brief, I'm not even going to dive deep into it, but briefly, he spoke about what it uses behind the scene. Why Spring Data JPA? Why not just stick with JDBC or something? And we talked about Hibernate, persistence context, and all these things, and how it actually boils down eventually to SQL. So just to find that, a lot of people say, oh, there's abstraction and programming. That's Spring Data JPA is one of them. Like if you start untangling, you see the bare bones of SQL, and all those stuff. And yeah, so today we'll be talking on the part 2 of it, beyond find by ID. Basically, that's just the title. And this will be majorly the traps. It's actually going to be majorly the traps, right? And I'll be going straight to, we have 5 traps. We'll be going, working it through, I'll be walking you through. And the first is the N+1 problem. The N+1 problem. I have heard this when I started programming and all. In fact, I had written this. If you go back to some of your code, so what you've done as a beginner, or as a beginner or something, you go back to your code and you are ashamed. You look at yourself, but then you are ashamed that, oh, did I really write this? But eventually you look at it and say, well, I've come this far. For you to have realized that, okay, this was terrible, this was not good when I wrote it, it means that you've really come so far. I've written this lots of times. Well, thank God it has not reached production. But what does N1 problem actually mean? N1 problem is one of the most common and most damaging JPA performance problems. And it happens when Hibernate, like I said, if you go to the part 1, you understand when I say Hibernate, you'd understand what it means and what it does, or how it even comes up in Spring Data JPA. It is what Spring Data JPA actually uses, basically. So it happens when Hibernate fires one query to load, let's say, a list of something from your database. Then it keeps firing, it fires. Yeah? Is that okay? So it fires more additional queries per entity to load, their related data. So for data rather. So for example, let me put it this way. Like I said, the mental model. So we would understand. The mental model is the lazy waiter. So who is a lazy waiter? You go to a restaurant with 10 of your friends. You go with each one of us here. Say you go to a restaurant with 10 of your friends. You call the waiter, he comes. And you tell him, this is our order. This is mine, and this for the remainder of my friends. So go bring our food. And what does the lazy waiter do? He goes back inside, comes back, gives you only your own, something like that. Then for each of your friends, he goes back to the kitchen, comes back, gives the first person the food, goes back to the kitchen, comes back, gives the second person theirs, goes back, third time, till it reaches the end, like the 10th person. So approximately, not even approximately, N here means 10. 10 friends. The N here means 10 friends. Plus 1. Basically, that's making it 11. That's 11 in total, which is not supposed to be, if you think about it. Why would you do that? Let's remove the constraint of, oh, maybe he can't carry the whole plate. What he is doing is, or he or she, what they were doing was just receiving your order again, coming back to take it back, go and prepare the food, come back again, take the order again, go back, prepare the food, come back again, like that. And that is a devastating stuff. Why is it dangerous? In production, you are not fetching 10 things. You know, sometimes you're fetching, let's say 100. Say you build an e-commerce product, and you're returning the list of shirts, or the list of like maybe 1,000 products or so, maybe 500. Then are you saying the backend, your code will eat the database 501 times? What if it's, you build social media, you build Facebook, and you have, say, 1 billion or 3 billion users? So you're going to go, anytime they fetch something, you're going to go back 3 billion plus 1 queries. Something should have done once. So that is what I'm going to treat today. And yeah, just like I've written here, or I typed out here, you know, you go to restaurants and all, you know, it goes back and forth and all. So the fix, what we should do is tell the waiter, go once and bring everything back in one trip. Go once and bring it back in one trip. So how do we achieve this, right? We're going to look at the code. 2 ways here, joint fetch and entity graphs. It all makes sense now. So let me bring up code, do a quick walk through here. It's very simple, very easy. We're not doing a whole lot. So if this font is too small or tiny for any of us to see, please, you can indicate. I'll bump it up. Right. So basically, this is our data. This is our seed data. We call it seed data. And what I'm doing basically is I have 5 authors, Nigerian authors, of course. Chinua Achebe, Wole Soyinka, Chimamanda Adichie. No, not Nigerian author. Yeah, Ben Okri and Ngugi Wan Thiongo. I hope I didn't murder that. And these are the 5 authors we have, right? African authors. Then we have this product. We have their books. We have 12 of their book, of each of them, you know, they wrote one book or the other. You have their books here. And this is going to be useful later on. This is just a list of users, not related to these 2 above here. So what we are basically saying is, by the time we run this application, let us have something in our database. Easy. Now, the entrance to it, basically, I'm just going to pick it one by one. Okay, we have controllers. We have controllers here. Don't worry, don't be overwhelmed by all this. And yeah, we have our users. Our author. We have an author here. We just need an ID for the author. We need his their name and email, basically. Now, this is going to make sense. See this particular line. It's a many-to-one relationship, basically. Many-to-one, or one-to-many rather. One-to-many relationship, meaning one author can have many books, which makes sense, right? Now, we are saying, okay, in our database, let these books be associated with this author, with a particular author. That's what the code is based. I'm just trying to dumb this down because I don't know if any of us are new to programming or something. So I'm just trying to dumb it down. Right. And this itself is the cost of the initial cost of n+1 problem. How? When you put your one-to-many, then you have, of course, you're mapping it to one author, that is a list of books to one author. Then you're saying this lazy, fetch type dot lazy. That means when I am looking for the authors, or when I'm looking for one author, for example, do not bring the list of this book along. I just need to know who the author is. So I'm saying, oh, when I'm looking for Wole Soyinka, do not generate or don't send all the books he had written also in the database. Don't send it along. Leave it. I'm only looking for Wole Soyinka. So that's why it is lazy. It says fetch type means lazy. Makes sense. And of course, we have books. Well, a book has an ID, fine. It has a title, makes sense. And it has an author. Of course, someone has to write a book, right? And this one is also saying fetch type lazy. Many-to-one meaning many books can be ascribed or can be attributed to one author. Makes sense, right? So, and this is also having fetch type lazy, meaning, hey, when I ask for a book, do not attach the author, basically. Don't just attach it, I just need the book. So, fine. Good. Now, for the n+1, this thing, we would be looking at logs. Like, let's run this application. When we run this application, it seeds this data into the database. We're using an H2 database, basically. Yeah, and it runs. Waiting for that to run and be up and doing. Then, we have a auto repository. Well, we don't need all these for now. I mean, for this particular part. Then we have our service. I just have to write a whole lot of service into this whole thing. Now, this is for the N1 problem. These three things are what we are going to just look at for this particular problem. So what does this code do? N+1 demo. I open it up. What does it do basically? It finds a list of authors. Find all of them, right? Then, for each of the author, it's saying, let us know how many books they've written. Simple. That's what it is doing. For each of the author, let us know how many books they've written. Right, I think our application is up and doing now. Great. Yeah, and for the purpose of this, I think I would use Postman just to have some simulations here. All right, great. Great. If I'm going too fast or if you have a question, please, you can ask. All right. So, we have local hosts. Local hosts. What now? Not all users. We're not getting all users. For our controller, n+1. All right, basically. Okay. Okay. So here's the important part. When I send this, you will notice something. So for the purpose of this lecture, or this presentation, I had echoed, or like I said, echo bash scripts. I've brought to the console Hibernate queries, SQL queries. So I'll just clear these ones. Now, when I run this, what do we assume? What do we want? We want, just like the service, what the service is saying. Well, we want that the database, our application goes to a database, gets the list of the authors. After getting them, return the list of books that they've written, or the size of the books, amount of books they've written, basically, right? Let's see what happens. So I should run this if everything is all good. I'll send a request. Okay. Oh, great. Okay, good. Now let's do this. How many authors do we even have? Let me access the database. So, okay. Let me. Like I said, I'm using H2. So yeah. Am I good? Yes. Yeah. Good. Authors. Run. Okay, I have 5 authors. Yeah, Chinua Achebe, Wole Soyinka, Ngugi, Chimamanda, Ben Okri. Great. Now, this query, it says, of course, select from the author, right? All the authors. That's cleared. Now, for each of them, access their book, the size of the book they've written, basically, right? Expectedly, just like our lazy waiter is just supposed to go to the kitchen once and return the food. But look at this, we have 5 authors. This is the first query here. This is the first one. 1, you say, oh, that is it. And that's for Chinua Achebe. 3 books. They have written just 3 books, which is evident. Yeah, this Chinua Achebe, that's the first person. Look at it. it goes separately to the database to look for the next person, which is Wole Soyinka. This is our database here, Wole Soyinka, 2 books. It goes again. You get the gist already. Making it how many? Basically, we have 16 books. This is the first one. This is the second one. This is the third one, third person, Chimamanda, fourth, and fifth. And if you look at it, you'll be like, it is fast. Of course, it's fast. Why is it not? It's you know, of course, hibernate, talking to a database, easy. But you have to imagine the overhead. What's going to happen if this was talking to 1,000 products or 1 million people, users? You're trying to fetch how many persons had liked Cristiano Ronaldo, or how do I put it now? Ooh, yeah, maybe Cristiano Ronaldo made a post on Twitter. You click that post, what happens? And you're checking how many people have liked this. You see 1 million likes. Now you click that like icon to check, hey, let me see the list of those that have liked it. You mean if we put this, if this was following our logic, it will do 1 million queries plus 1. That's 1,000,001. It's not efficient at all, right? So that is the first issue. That's the first issue. And why does this happen? Well, this is happening simply because of our lazy, we're fetching things, we were saying, oh, lazy this thing. This JPA, Spring Data JPA by default, basically. This is what it does. This is default. This is not an anomaly. Say, hey, they made a mistake when they built Spring Data JPA or something. No. But then, how can we circumvent this? How can we go over this? Well, there are 2 ways. The first fix is this, basically, entity graph. What does entity graph do? Well, let's go to authors. This is the first one. You use a query. You write your own query, basically, right? You write your own query. It runs once, right? So when you write your own query and it runs once, it disallows this back and forth that what is it called? JPA would have done. That back and forth that it would have done, it does that. So when you write your own, you put entity graph and write your thing. That's this year, right? The first one, all books, entity graph. When you write that, the query is going to run just once, right? And that's why a lot of people actually prefer to like write their own thing, right? Which makes sense. So ideally, how do you use the entity graph is an annotation. Look at it here. Right. This is the code. This is listen, right? So you fetch all the authors, right? Once, with entity graph once and all, and when it goes, and instead of it going and coming, just like the previous one, it does everything once from your query. And let us see that in action. Let me clear my log. Let me clear this so we can see. Postman again. Oh, what should that be? Demo controller. Entity graphics. Right. Good. So yeah. Oh, 2 slashes. Pardon me. Okay. And then send this. Oh, we've now added our entity graph. Oh, nice. Oh, sorry. The same thing. So let me put our entity graph at the X. Yeah, exactly. So here you go at entity graph. So what does entity graph do? Basically, you're saying, hey, when you're fetching this person's, fetch your attribute, this particular attribute, or add these things when you're coming. add the list of, for the restaurants, they're like, hey, add the list of add our food basically when you're coming back, when you're returning. That's what this does. So when you use entity graph, it attaches the books so that if when your service is using them or is going to use them at all, it's going to be like, oh, it's been cached. It has it in memory. It's not going back to find it one more time or extra steps, right? So I think we have to then run the code here again. Oh, pardon me. Yep. Shouldn't take a while. This is building. Okay. So while that is running, just so we don't, because of time, this, the other one, the other solution is to use a join fetch. A join fetch is basically saying, hey, when you're coming, just join the books. When you're coming, just bring the books alone along. I mean, with the books with the authors along. So I can use them once and for all in my query without doing extra steps and all. So yeah, let us get this off. Let us send this. Now, what do we have? Just one journey. You know, the first journey is we want to fetch the authors, right? And the other one is just bring back with them. Select, just as you're coming, bring back the books. All for the sellers. Now you see, Chino Achebe here, 3 books, Wale Soyinka, 2 books, this Chimamanda, instead of what we saw earlier, right? So that's what that does. Same thing with entity graph, join fetch, right? The same thing with join fetch, which is here. This join fetch is just basically as you're coming, join, select A from author, select all from the author's table with, join fetch the books that they've written along. So you don't have to go back and forth anymore, And yeah, you can ask, what's the difference between both of them? When should I use, when should I do that? Well, it's just basically preference. That's first thing, and control. For this, I just have to put this entity graph. For this one, you have to know your SQL. That is for join fetch. And for join fetch, that means if you want to do something so complex, not just attach their book, or maybe attach their book, and especially if the book was published in this particular year, you see you're already complicating the data. That one you can easily write it with SQL. But for for entity graph, that will become complex. So this one is easy, it's just an annotation, while this is basically your own flexibility, write your thing. And that is that. For that, the second issue is lazy initialization exception. And what does lazy initialization exception mean? Basically, it's saying, so I will give you a scenario. And that is actually, if you join the first class or the first session, you would actually understand quickly. So we have a manager, like we had an example there. We have a manager that looks over a factory. He looks over a factory and registers what people are doing, or they come to him, the workers come to him, hey, I just did this, he will write it down. I just did that, he will write it down. Now, when it's 4 o'clock, everybody closes, right? So the workers leave. The manager takes the notebook that has been jotting things down and goes to give the HR, hey, this is the record or the log for today, right? Now, if at any point in time, the manager leaves the office and locks the door, or even the HR leaves the office and locks the door, the manager will not be able to report anything, right? So everything he has in his hands are just waiting. It's locked. Now imagine in the manager's record, he has that 25 people worked today. In the HR's document, because he had not received anything, 0 persons worked today. Now imagine you're asking the HR, or maybe you as the MD, you're asking the HR, so how many people came to work today? Expectedly, the HR will say 0 people. Meaning, by the time data is coming, or data was resuming from the manager, the HR had already closed. That is the closed office, basically. So lazy initialization concept is basically like trying to access something when the opportunity is closed. And we mentioned persistent context then. We said persistent context, basically how JDB, Hibernate rather, those things. When you say insert this data into the database, it doesn't do that immediately. What it does is Hibernate holds it in a persistent context. Then it processes it and then gives the database a, hey, write this thing. Right? So while that transaction is still open, that context is still available. The moment the transaction ends, the context is closed. Now imagine your application is asking the persistent context that, hey, yeah, part of that thing I said you should do before, also do this with it. And that one is like, hey, I can't recall. I mean, this transaction is closed, basically. And so how does that work in code? Well, you will see how a whole lot of persons actually fall into this, right? So for that particular part, we are going to go, what's the service? We're going to look at the service and we're just going to, okay, so as we do this, we just close it up, I guess. Yeah. So this, we have lazy initialization. So what does it do? You get your authors. These are the same authors we'll be using. You get them, and you're like, that's what our service here does. It gets them and returns them. That's all. And remember this thing, I don't know if any of us we've used transactional annotation, right? So anytime you call this method, it sort of like snatches that call. Like, it just snatches it. And within whatever you do within this thing, till you return, or this method is done, everything is just a transaction. Makes sense. So for this our method, we are just saying, hey, provide a list of the authors. That's all. And then return it. Now look at what our controller is doing, which of course you don't do logic in controller, but for the sake of this, we just add 2. We just add 2. Ideally, so what's our controller doing? Look at it. It fetches the author. Fetches the authors, right? Makes sense. After fetching, the moment you say you call, this method is called and it returns the information, transaction is closed. Ideally, where's our service again? Transaction, because it had returned already. So transaction closed. That's why we have this transaction now. Now imagine what the controller is trying to do. After it's closed, saying try to access the books per author or per one author or something like that. And you just already know that your code will not reach here. You're not getting, because the database is closed, the HR is closed, basically. Right, so let us try that. Let's say it looks, once again, doesn't of that should be lazy exception. All right, type that out. So we're saying, okay, lazy exception. And so, okay, we even got a 500 internal error, right? Of course, we're not handling the error well. It makes sense. So yeah, he found the error, the author for you. The transaction is still open here. But look at it. This is actually an error from, this is not something I wrote. This is an error coming from JDBC itself. It's saying lazy initialization exception caught. Failed to lazily, if I just, the use of the word lazy, failed to lazily initialize a collection of rows. Could not initialize proxy, no session. That session is closed. So times where you write code or you write your program and you're done, your transaction is done basically, and you're still trying to reach to that, reach to the database after that transaction is closed, you will get this kind of error. And these are the traps. And imagine you've built, of course, you can't foresee something like this in your mind. You say, oh, in this try and catch, I still have access to the author, basically. But that service is, that thing is closed, long gone. And then you are building a whole lot of it from it. Oh, from their books, do this, do great and mighty things. No, you're not doing anything. It's gone, right? So that basically is about this. So the call here is don't try to access something when, of course, this context service, the persistent context is already closed. You don't try to access things, or don't try to do things like that, right? So that is that about. I'm trying to speed this up because of time. And basically just looking at the foot traps, or then like the foot guns that one can do unknowingly, right? Okay, so yeah, the fixes, right, as you can see here, good. You can fetch what you need inside your transactional boundary, which makes sense. Or you could use entity graph like we did. So to fetch everything down that you can just use in your code. You can also use DTO projections, right? You can use DTO projections. And what exactly is DTO projections? Well, we'll get down to that. It actually gets close to that soon, right? So yeah, now transaction boundary. This is the third one. I said we have 5, and we're rushing through it. Transaction boundary traps, basically. And what this does, basically, is, like I said, transaction, that annotation you see, this is our transaction. Where's that again? I think I can close. No, I can move this. We can close this transaction. This transaction now that we put here means, hey, for this session, do this thing. If any of it should fail, roll back. If you're very vast with SQL, for instance, not even SQL particularly, yeah, maybe database, let me call it database actually. So when you write some series of things and you press commit, I think before you write commit, if you write a query, for instance, you can still roll back. You can roll back that, hey, sorry, what I did, roll it back. But the moment you write a commit this thing, it's done. Basically. So that is what transactional actually basically does behind the scene. I think since we talked about internal, I think we would have just opened these and check what does this even do. But this is a Spring, this is AOP, aspect-oriented programming, of course. And yeah, read only, no rollback, there's rollback and all these things. You can go deep into it, but because of time, that's not the goal, that's not the target. This is something we could have discussed in the first session, actually, when we're going deep into what these annotations are now. So basically, the issue with this is, even when you say something should be transactional, it doesn't mean that. Normally, what it means is, if anything should happen during the running of this program, if anything should happen, roll back all I've done. If I said transfer 5,000 to someone, and during the course of that thing, network or something happened or so, just roll it back. Credit me back. That's basically what transactional, for that space of time, that within the thing, everything that is happened anything that you say should happen happen once, or don't even do it at all. Now, look at this code. We are saying, hey, this service is transactional. Fine. You get a user, part of our users. You are trying to add a new user. We set the name to ghost user, example, their email, their role, their status. And we actually, on this line, we said, save the user. But look at it. On this new line, we said throw an exception, throw new exception. An exception, of course, means like, hey, something went wrong. Ideally, everything should roll back. You should not see this user in your database. But of course, you are in for it. You will see your data. You will see this user in the database. Why? Well, let's run it first and check it through. This is our current. Are we still good? This is our current user. Sorry. Are we still here? Yeah. Oh, I knew it. Connect when I restarted the server. So these are the folks we have. We have Timmy, we have Kunle, we have Amaka, we have Emeka, we have Ngozi. Basically, we have 5 people as users, right? We just have 5 people as users. So we want to add another person. But at the cost of adding another person, we threw an error, like an exception that, hey, something great. We are purposely doing it, of course. Expectedly, it shouldn't work. So let's see. I think now we're having normally the exceptions. We have check, no rollback. All right. onto, then paste this, then run. Right? We added. As a matter of fact, if you see it's saying insert into the user and all, hibernate insert. All right, let's see. Run. How many users do we have? Look at it. We have 6 users. Meanwhile, we threw an exception. In fact, it says exception caught. Because there's something went wrong, but it's still committed the transaction. And so you'll be like, oh, if an else statement or something like that, I'm trying to look at the use case here, or where you can come into this. You are adding someone, or no, you already said, oh, you should save. Or if you're not trying to get that person to use the ID, if it does not exist, throw an exception. Maybe, yeah, if I throw an exception, of course, it will now roll back. No, you've added the user. It's gone, basically. And they're like, why? Why? Is that not is that not what exception is there for? Well, transaction boundary traps, basically. He's saying, hey, yes, I get it. And this is also a mistake. This is not a Spring or Java made a mistake, or Spring Boot, people would have written made a mistake. What's happening and all? That's what it was designed for. It's coming from AGB. Yeah, if those are no AGB, that, from AGB and all this old stuff. So it's by design. I'll just put it that way. Basically, I don't want to go deep into that for now. And why it's happening is we are not specifying, even for transaction. Let's go to transaction. Let's open that source code again. Yeah, we're looking at it. There is some things I saw rollback. Okay, this is read-only. For those that used to put read-only in their stuff, this is where of course, this is where it comes from. This is where you say, yeah, rollback. In fact, it's throwable, exceptions and all. Rollback for, and it says defines 0 or more exception name patterns, blah, blah, for exceptions which must be a subclass of throwable, and this and that. This is your Java fundamentals, actually. Because we did not specify a rollback for, and for which exception class is fact, I think you can specify for IO exception and it could still go in. So you have to really be careful. Because we didn't specify an exception class, that's why that delivered. Now we attempt again. Let's say our ACA was like, that one went through. Let me try another user. This one is ghost user 2. The first one was just ghost user. Let's try to throw this person inside. This time we also just the same code. We are copying just the same code from that one, but the difference is we are specifying that it should roll back for an exception, for exception.class, any child of this. Basically, this. We are specifying it, right? Now let's try that and see. So once again, what do we have here? We have just 6 users. Now, roll back with send. Oh, and I should be showing this self. Sorry. I think I should cancel that. I should try it again, send again. Great. It tried to insert the same thing, but it got a warning, it got an error. And because we've specified it, if we check the database, like, okay, do we have a user here? We still have just 6 users. Ghost user 2 is not there. This is the initial ghost user that went through. And why? Because it is rolling back. It's English. It's just English. It is rolling back for this particular exception. Where's that? Yeah, this particular exception is saying roll back for this exception class. And this is what we threw here, the exception. Let's try something. What if I do IO exception? To be honest, I've not tested it. I don't know if it would work. I would have thrown this out if not because of time. Would it work? Would it not work? Would it save? Would it not save, basically? Let's see. Yeah, we are still on the right thing. Okay, send. Right. I should have thrown this out and left this out as there's a goal for this or there's a gift for this, but now run. It did not work. Basically did not. Why? Because exception extends this. Basically, I think this is checked also, right? Because it's extend that. I'm trying to, I think I know SQL exception. I don't know if it, yeah, I think it's extend. Does he extend? Let me see, does he extend it? Import the class now, come on. Let me see, a moment. Extends Java language exception. Don't worry, let's just move on. There's no error I'm going to try now. Maybe unless you define your own error, right? You define your own error. Oh, I didn't start the server again. But then, yeah, I don't think it should work. I don't think it should work. Let's take that leap of faith and try it. Let's just take that leap of faith and try it. Let's go through it. That's the thing. Curiosity. What happens? What I go on? Yep. Right. Okay, delete. I don't want to see your queries and all, delete it. Yeah, I think that should be all. Yep, that's all. So, we have to start all over. No, not necessarily. Or for now, let me click run, logs me out, connect again, check out how many app users we have. Yeah, we currently have 5. Come here, log this person. All right, fine. Let's see. Please show me. It's still fine. I guess it's right because, of course, it extends exception, and if any of the exceptions you're writing, if any of the exceptions you're writing is a extend exception, of course, yeah. I think should you run for? Let's check runtime exception. No, let's just move on. This is 922. Let's move on. These are the things, man. You go through these, you just want to check what happens if, but trust me, we are doing it. Doesn't matter. We are doing it regardless. We'll reload again. Yeah, this is curiosity. So that means when I was coming up with this, I was doing the happy path, happy tests, which one works, which one does not work, and all. This is on the go, like, me being curious, did it actually work? Be fast. Oh, come on. We should be done. Come on. Right, we're done. Connect. Right. So we still have, these our users. We still have this 7.5. Try it. Send. Pray. Runtime exception. Run again. Let's just move on. All exceptions are covered, but I am sure I'm placing a bet. If you write your own exception, I don't think it should. Well, of course, the extend exception, right? Runtime exception, it's fine. We are protected. But then the goal and the lesson of this is, regardless of the fact that you said through an exception or something, well, I'm under transactional. The transactional should not work because, of course, something broke during the period it was transacting or the transaction was going on. Now, if you did not specify, if you don't specify the class, if you don't specify the class of exceptions you're watching out for, roll back for this particular class, you're in for it. You're in for it. And yeah, that's basically that. And projections, basically, we have little time. So projections, what does projection mean? Yeah, so when you go through, for example, when you go through, if you travel, you're using the airports, for instance, yeah, you don't get to be, like I said, the passport, mental model, the passport. You don't get to be asked, where's your tax ID, where's your date of birth certificate, they just get your passport, what they need. And from there, they probably check your serial number and your name, and from there, they get all they want or something, and they let you move on. They let you pass through. And so what does that, what does that have to do with what we're doing today? Well, basically, if you have to I know quite a lot. I did it. Like I said, a lot of these things I felt bad going back to look at my old code because I'm like, oh no, I really messed up. But thank God for growth. If you have to look back to the code you've written, Java and all these things, you see that you had called something like find users, or I'm trying to look for something like that. Of course, I didn't write. Yeah, find authors. Yeah, author is going to return everything, the ID, the name, the email, okay, not the books. No. Imagine you have 20 fields. This is just 3. If you have 20 fields, maybe for products, e-commerce products, for example, and there's a lot of fields, and all you need is just the price or something. But because you're saying fetch that product, it will fetch the whole of the fields. And what does that mean? That's a lot of overhead, to be honest. Everything costs something. Computing, you're taking at least more memory. You're not getting it fast. You're getting a slower response because you're just querying the database to find that particular row, to return the particular field, to encode it and serialize and all these other things. You might not see it. You're like, I don't care about this. Well, you don't care because it is small scale, I guess. Right? But all this, every second matters eventually. Right. So projections basically saying, hey, you don't always have to send in the whole of the fields and all this stuff. You can easily just send what you want. And how you can get what you want, we have at least 2 ways, or at least, yeah, let me put it, at least 2 ways you can. The first one is you can do interface-based projection. Interface-based projection. And what that basically means is, let me see, user summary. Good. In my user, in the user here, user. In the user, at most, we have, okay, I'll just use this one. We have ID, email, name, role, status. But I just need their name and email alone. So do I have to fetch every entity and every field? No. Basically, you can use an interface, define what you want as like a method. Really, you put your brackets and all. Right? That is interface-based projection. And how do you use it? If you go to the app, this is a repository of this thing. Right. This is how you use it. This year. Basically. You say select new from, of course, the full path. And kudos to NAIJA-JUG once again, just like a break from here. In our distant bootcamp, we were taught this ideally, and it's stuck, really, it's stuck, right? So if you're not part of it, please join. And you're new to programming or something, or even if you will get a lot of things to learn, even more than what you've known before. I can assure that. Basically, I can put my money on that. So we're taught this, for example, interface projection. So this is a link to the whole thing. This is the user DTO eventually. The user DTO, right? And you're saying, hey, from this, no, the user DTO, sorry, entity. Yeah, of course, user DTO. Yeah. The user DTO, I need the email and name. Basically, I think we're done with authors. Yeah, can just come here. I need the email and name alone, right? And it returns that to you. It returns just that to you, basically. And so let's find it. Let's see. I think we have an endpoint, like I say, an endpoint. We have a controller, projection interface, basically. A query. Yeah. So look at it. It gets just their name and email, not the whole of them. Not the whole of them. Gets just their mail and email. Where's the service? Yeah, this is the service. This is what it's doing. Get users. It's you. Basically. This is what it's doing. Just gets their name and the email. And that's how you use that. right? That's how you use it. And look at it once again, in case you're confused about it. Where's the, yeah. Thus, basically. So you just get what's, oh, this is actually, oh, summary. Yeah, user summary. We needed the user summary alone. This is it. User summary. And this is user summary here. We're just getting the name and the email. You just pass that. You're not writing any other extra thing. Find by status. And that's why we say this is beyond. That's why the type 2 of the this is beyond find by ID. Right? Now you're using find by status. You're not even using the users, but you're using just a user summary. You're using user summary that just has, is an interface that has just 2 fields, methods, if you like. And that's all. See, clean. And all this just makes your stuff clean. It makes it so clean, right? The other thing you can do is DTO projection. DTO projection. And that's where this one comes in. This is user DTO. Yeah, I know a lot of us use user DTOs in like different, you use DTOs rather, data transfer object, different ways and all. This is one way also that you can use it. So yeah, that's what I'm using here. Find active user DTOs. Right. You're saying the user DTO, you've passed the user DTO, which is this, in your query. Just return to me the name and email. I don't need the ID. I don't need their what's the status and all those things. And the same thing, just that this one looks more verbose, right? You're writing your query with your end, right? And Spring Data JPA does its thing and returns it for you. If we go through the same this thing, if we go through the endpoint, it should return the same thing. Projection DTO basically. DTO. Right. Okay. You see, it returns the same thing. Just exactly the same thing. And so that's easy. And you look at it, how is that a trap, basically? Well, the thing is just for you to make things faster. You're not loading their ID, you're not loading all their stuff. It makes, like, see here, it says cleaner queries, less memory pressure, faster responses, basically. So it says projection tell Hibernate exactly what fields to fetch, nothing more. No extra network bytes, no extra memory, no extra distance, kilobyte or so. And so that's just that. So of course, you can look at both of them and say, when do I need to use one or when do I need to use that? Well, like I said, interface is just simple. You just declare the getters basically, and Spring handles the rest for you. Cool. Right? And you see it's best for simple field selection. While the DTO projection, of course, it uses a whole class. Look at it. We actually wrote a whole class, DTO, for it. We got the field, and of course you can do this and all. We have to write all those things. But the good thing about it is you can control the mapping explicitly. You can add methods and logics. Look at it. We wrote to string here. Right? In our DTOs. You can also write, of course, complex JPQL. And it's best for complex queries or when DTO needs behavior. So the choice is yours, basically. Right. And of course, the fifth of them is the modifying gotchas. Right. The modifying gotchas. This is quite interesting. This is very interesting in that, and it's important, honestly. So when we talked about the first session, for those that were there or for those that would go to watch, you can note this down if you go to watch. We said anything Spring Data JPA does, it gives Hibernate, because it's using Hibernate behind the scene. Hibernate passes it to, of course, because it has its own in-memory platform, let's put it that way. So Hibernate passes it to the persistent context. And from there, it goes straight to the database. So just see that persistent context as Hibernate notepad, right? Now, anytime you use modifying annotation, when you annotate your queries or whatever with modifying, instead of Spring Data JPA to give Hibernate, then Hibernate gives its in-memory this persistent context, the persistent context gives it database. It actually automatically bypasses the persistence context. That is Hibernate's persistent context and goes straight to your database. Let me put it in shape like this. You tell Spring Data JPA, load 500 users, especially when you're doing something like bulk update. Load 500 users into my database. Spring Data JPA takes that query, gives Hibernate. Hibernate turns it to SQL and all this whole thing, gives persistence context. Persistence context says, okay, 500 users, right? Fine. It gives the database. Right. Now, you're saying, oh, modifying, you put modify. I will show you how you put it. You're like, you know what? For those 500, instead of 500, add 200 more to make it 700. But you put modifying because you're doing a bulk update thing, right? Good. What does it do? Modifying gives Hibernate, of course. Hibernate keeps the persistence context. Meanwhile, in the memory of the persistent context, it just did 500 users. So Hibernate gives the database directly, hey, add 200 more users. Now you can taste the data inconsistency. Persistence context is still saying, oh, we have 500 people in our database. Makes sense. The database is saying we actually have 700 people in our database. Let's see how this works in code, or let's see the workings of this in code. Basically, this is how you use this is how you use modifying in your repository. This then interface, this is how you use modifying. You write modifying here as an annotation. That's all. Right? Now, let's quickly run through this. This is, of course, the last one. Great. Once again, before we go, let's check our users. Yeah, because they are going to be instrumental in this. You can see we have 5 users. The first and the last user are both admin. Right? That's clear. Every other person, their role is just user, and only one of them is inactive, and that's Emeka. Emeka is inactive, right? Good. That's what we currently have. Now, see what happens when we use modifying. We're now telling this is modifying. We're telling this is a bulk update. We are saying, hey, find all the users in our database. Right? Find all the users. That's what this is saying. This part is saying. And it's saying, now, update the users, their roles, basically. Update the users. For everybody that has a role that is user, update their status to inactive. So basically, Kunle here, we have to change to inactive. Amaka, we have to change to inactive because their role, of course, their role specifies user. Emeka is already inactive. So yeah, so we expectedly, when we run this, we should have active, inactive, 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 active. Right. Let's try that. Let's run it, of course. Yeah, bulk update. Let me bring this up, clear it, send. Send. Basically, it has done in its own mind, it has done its thing. Right? Meanwhile, because I logged the data, or I logged them out, Kunle is still active. In Hibernate's memory, that is the persistent memory, is it Kunle here is still active. Amaka is still active. Emeka only is inactive. You know, we said it should display only those users that have that have user as role. So in Hibernate's memory, it's still this. So in case you are running transaction now, you already know you are dealing with a stale data. right? Now, the way to circumvent this, and like, okay, how do we go about, how do we move forward with this? Is basically by specifying in our repository, specify clear automatically, flush automatically. Both of them should be true when you're using modifying. Clear automatically, flush automatically. What does clear automatically do? It says, A, hibernate. Throw away the notepad after the bulk update. So the moment we added 200 persons, it's telling Hibernate, the moment modifying is adding it directly to the database, it's telling Hibernate, hey, that whatever notepad you have before that said we have 500 users, throw it away. Basically. So you won't have anything. So if at all a query is coming, it will go straight to the database and get the updated stuff. Now, flush automatically is saying, hey, whatever pending writes we have, flush them before the bulk updates run. So we don't have issues. Whatever you're still writing in that context, flush it to the database. So I can add these 200 guys. And so remember, this is what we have in our this thing. Oh, I cleared it already. When that ran, we saw that Emeka, Kunle and Amaka were still active. Right. Now I would run this, which is of course our whatever the last thing we are running today. Still think that should be not get our users. No. No, this is still okay. I think I remember it's fixed. I wrote it fixed. Send. What does this do? It had cleared it, and look at it down here. Kunde is inactive. Amaka is inactive. Emeka is inactive. Basically, so you run this. All of them are inactive now. So when you're using, and I've seen that it's not, these are actually, there are more other traps, but I actually picked based on my own preference, of what I've seen. What does this modifying do? And I'm like, oh, this is what it does. And like, oh, there are traps for it. You see, flush automatically, clear automatically. And you can read more. It says, indicates that a query method should be considered, blah, 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 blah. You can go more and read on it. So basically, these are the traps you should watch out for when you're doing things, when you're coding, when you're writing your code. You can go back to your own code that you've written from day one and say, okay, where have I actually messed up? Not necessarily messed up. Where have I done things without knowing? Which just shows progress, basically. It just shows progress, basically. So for N1, for those people that use fetch or lazy fetch or something, remember that you could be doing N+1 trap. Yeah, you could just do entity graph or join fetch. And that means you even have to know your SQL, which is important in this AI world. Know your SQL, right? Lazy initialization also, we talked about it. When you're trying to perform an active a transaction outside, or when you're trying to perform something outside a transaction that has been closed, you won't get anything. It's like a bouncer. It's basically like, but there's something about, quickly, just so before you go in, there's something about lazy initialization though. If your method in your code is a private method, it can still communicate. It's like, oh, it's, for example, I'll just give an analogy. You go to a place, there's a bouncer at the door. If the bouncer allows you in, anybody that is outside and is calling your name, you cannot hear basically. So they can't communicate with you. So if they are trying to perform a transaction with you from outside, you can't get it because, well, basically you are in already. Something like that, right? But now, if the bouncer allows that person in, whatever you are talking about, the bouncer here is a transaction. The bouncer starts from transaction now, that annotation, transactional. Now, whatever both of you are talking about inside, the bouncer knows nothing about it. So you can literally probably even delete your database with a private method, even when you're using transactional or whatever. The point is just that transactional, of course, hijacks calls that are coming from outside. But when your method is a private one, hey, be careful. be careful, basically. You can do things, right? So that is like 5 of the major stuffs we have. And I think with that, we'll just wrap up because time, right? We'll just wrap up. And that was a conclusion of, we started of our Spring Data JPA session. We started with the bare bones, what happens behind the scene. That's what we started with. Then we came back up, like, okay, what are the mistakes we can make on top, and what is actually, how is it translated to what is happening behind the scenes? So I implore us, you can go to NAIJA-JUG, NAIJA-JUG our YouTube channel. There are a whole lot of things for free there. Honestly, go there and sip from the knowledge of those I've shared, right? And everything will make sense. Thank you very much, everybody. Thank you.
Thank you, Awoniyi. If you know you've learned something new, I just want to see your reactions. It's just John and Ebube I've been saying since.
That even was I have learned something.
That was also Awoniyi. Is there any question before I give my? If there's any question, I'm not surprised, but if peradventure there is any question, you can raise up your visual hand. Wow. Yeah. I think he also shared the slide as well.
Yeah.
And whatever he used. So I want to thank you so much. Like I mentioned earlier that he's actually a pain in my life. Yeah, but he's a great person. Yeah, he's a great person. So thank you so much. Thank you for all you do for NAIJA-JUG. We really appreciate. The video will be live hopefully tomorrow, so you can revisit. So is there anybody here that is not on the platform? Can raise up your hand. Riches, Oscar, James, Janet. You guys are on the platform. All right. So thank you so much. Apology for exceeding our time. I know if I allow him, he can still spend 3 hours without getting tired. Yeah, that's just him and his passion for sharing his knowledge. So we are grateful. And for those here, thank you so much for joining us. And like I said earlier, we apologize for exceeding the time. Yeah. And please, we are, yeah, okay. We'll expecting Judge Long this month's end. Please, if you're on the LinkedIn page, LinkedIn group, on our Twitter, please kindly retweet, repost, share, so your friends can see. We need the audience, please. Please. Thank you so much. And we'll see you same time, same station next week, Tuesday. Yeah, thank you so much for your time. We really appreciate, and do have a lovely night ahead. Thank you, Awoniyi. This time, I will not say it, but thank you very much.
You're welcome. Thank you.
Let me not add to the one I'm owing.